Our last example from this section is same type thing. Find the radius of convergence and the interval of convergence of the series. We'll do the ratio test one more time. The limit as n approaches infinity of, I don't actually need, well, I'll keep it. Absolute value of n plus 1, x plus 2 to the n plus 1 over 3 n plus 1 plus 1. I'm going to write it as that instead of plus 2, since I'm going to want to simplify it with some 3 to the n plus 1s. So here's our ratio test, and I will do some algebra. We've got n plus 1, x plus 2 to the n times x plus 2 times 3 to the n plus 1 over 3 to the n plus 1 times 3 to the first times n times x plus 2 to the n. Now, let's simplify x plus 2 to the n, x plus 2 to the n, 3 to the n plus 1, 3 to the n plus 1, and that looks like everything that can cancel. Now I'm going to collect the n terms together. So we've got n plus 1 over n. We've got a 1/3, and we've got x plus 2, like so. Now we know that n plus 1 over n is positive, since n is positive. We know 1/3 is positive. The only thing that could be negative is the x plus 2, so that's the only thing that we need to keep in the absolute value. I'm also going to multiply the numerator and denominator of this first part by 1 over n in order to get a limit that I can evaluate. So that gives us 1 plus 1 over n over 1 plus 1/3 times the absolute value of x plus 2. This limit is 1. Why is this plus here? That's times. Times. This limit is 1/3. That limit is absolute value of x plus 2. And I want to keep this less than 1, which means I want to keep absolute value of x plus 2 less than 3. So that is our radius of convergence. It is r equals 3. So the interval of convergence, now we do our absolute value thing here and subtract 2 from both sides, giving us -5 x 1. Okay, now all that's left is to determine what's happening at the endpoints at 5 and at 1. When x equals -5, then what happens? We've got the sum of n times 5, -5 plus 2 is, sorry, yes. Where's my stuff here? -5 plus 2 is -3 to the n divided by 3 to the n plus 1. So what does that simplify to? That simplifies to n times -1 to the n times 3 to the n over 3 to the n times 3 to the 1. Canceling here and here. And what's going on here? We've got the sum of n over 3, and it's alternating, but as n gets large, you need this term to go to 0. So this diverges by the test for divergence, since we'll call that a sub n, the limit is not 0. This limit needs to go to 0. Alright, so it's no good there. And then when x is equal to positive 1, we've got the sum of n times 1 plus 2 is 3 to the n over 3 to the n plus 1, which is the sum of n divided by 3. Not alternating, but also divergent, since this limit is not going to 0. It's going to infinity. So what's our final answer? Our final answer is the radius of convergence is 3, and the interval that we're looking for is from -5 to +1. And that's the end of that one.